Good evening, everyone. We are in the week 11 problem solving session of the NPTEL course Network Analysis. And week 11 is about series, parallel, and cascaded connection of two-port network. I am Teja Golla, a fourth-year research scholar working under Dr. Santanu Kabat at Embedded Power Management Lab, IIT Kharagpur. Let me share my screen. Can you see my screen? Hello.
Yes, sir.
Okay. So in the last week, we have discussed about two-port network, the convention and different type of parameters, starting with Y parameter, Z parameter, T parameter, and H parameters. And we have solved a few problems to understand how we can get those parameters. But today we'll see some complicated circuits, which are like a parallel combination of two-port network, or could be series, or it could be cascaded connection. And we'll see what type of parameters will be helpful in which scenario, and why they are helpful, and how to proceed further. And we'll solve a couple of problems to understand what we'll be learning today. So I'll start with the series combination. Series combination means input is connected in series. So let me show you what I mean by this. Um, we have a two-port network here, and we have another two-port network here, and let this be inputs. This is also input. This is output for both the ports. So I'm calling this network N1. I'm calling this network N2. So let this voltages be plus minus V1, and note the direction current I1, and this is I2, and plus minus V2. So let this be V1 dash, and current is I1 dash. This is I2 dash, and voltage is plus minus V2 dash. Now they are connected in series. So basically, these two are connected, and these two are connected. So now what will be my actual output input? So this is my actual input, because we are supplying the voltage as a whole. So now the voltage becomes V1 plus V1 dash, and here it is V2 plus V2 dash. But if you see, current still remain the same. This is I1, and this is I2. And if you see, I1 dash will be equal to I1, and I2 equal to I2 dash, because they are connected in series. So they are taking the same current. So now we have to get the overall relationship, meaning, say if we have considered this entire thing as a single port network. If we consider this entire thing as a one two-port network, say now we are trying to represent this as single two-port network. And let the network be named as N. Now we have to get the parameters of this N. So any idea which parameters could be useful in this scenario? Like because we have four parameters, Y, Z, H, as well as T. So in this scenario, which parameters will be helpful? Anyone, any idea? Did you understand the question? What we are trying to do? ABCD. Parvatam says ABCD. What about others? Nandini says Z parameters. Shamita. Okay. So, yes, yes.
ABCD parameters.
ABCD parameters. Okay. So, first of all, how are we going to know which parameters are helpful? So, ABCD, if you see, it is input versus output, versus output. But if you see in this case, the we cannot get because input versus output, if you do this input and this input is not exactly same, nor the output of this is same as the input of this, because we need to have some common terms so that we can get the overall parameters. So if you see here, current is same in both the cases. Here also current is same in both the cases. So we want the same parameters to be on one side of the equation. So as currents are same, so I want currents to be on the LHS side or it could be on the RHS side. So either it is Y parameters or Z parameters. But what is getting added? Voltage is getting added. So if my voltage is on the LHS side, then it would be easy for me to add, right? So that's why we will be using Z parameters. Once I write down the equation, then it will make more sense. So here we have I1 is equals to I1 dash as well as I2 equals to I2 dash. So if I consider network N1 and the voltages are V1, V2 is equals to parameters Z11, Z12, Z21, Z22 multiplied by currents I1, I2. Similarly, for network N2, we will have voltage V1 dash, V2 dash is equals to, say these parameters are Z11 dash, Z12 dash, Z21 dash, and Z22 dash. Into currents are I1 dash, I2 dash, which are same as I1 and I2. So now if you see, I can add these two, right? Because on the RHS side, I have certain things to take common. On the LHS side, I want V1 plus V1 dash. Here also V2 plus V2 dash. If I take Y parameters, then it would be difficult for me to add V1 and V1 dash because there will be Y matrix here. So that's why we are considering Z parameters here. So equation 1 and equation 2. Now what we'll do is equation 1 plus equation 2. So on the LHS side, what we'll be getting? Anyone? What will be the expression on the LHS? If I add these two, if I add these two, hello, Nandini, V1 plus V1 dash and V2 plus V2 dash. Yes, very good. So we'll have V1 plus V1 dash here and V2 plus V2 dash here. So I'm making this on the LHS side. So now these will get added because there is common Z11 plus Z11 dash, Z12 plus Z12 dash, Z22 plus, sorry, Z21, Z21 plus Z21 dash, Z22 plus Z22 dash. Whole thing multiplied into I1, I2. So now if you see I1 and I2 are the currents and V1 and V2 is the supplied. So now this will become our new impedance matrix. So this becomes our impedance matrix. because V1 plus V1 dash is the now input to this new port, and this is the output to this new port, and currents are still I1 and I2. So this is my impedance matrix, new impedance matrix. So just to summarize, what can I say? The impedance matrix. Okay. Series connected two port network is the operation of the impedance matrices of the individual two port networks. Is this fine? Is this concept clear? If it is series connected, how we are getting the parameters? If you have any doubts, you can ask, else we can proceed to the parallel combination of two port network. Any doubts until this point, anyone? Are things clear? Current is also I1 plus I1 dash. No, why? Because here current is I1. The same current is going I1 dash. So I1 is equals to I1 dash. Because it is series connected, voltage will be added and current will be same. Because the same current is flowing and here it is coming out and again it is flowing. So that's why I have written I1 is equals to I1 dash and I2 is equals to I2 dash. Because they are series connected, current should be same because it's a series path. If it is parallel, then current will be added. Is that clear? Okay. So now we'll go to the parallel combination of two port network. So now again we have two port networks. Let us name this network same N1 and N2. And again let the voltages be plus minus V1 and current is I1. Here also plus minus V2 and the current is I2. Here also V1 dash, same as what we have considered previously, I1 dash. This is plus minus V2 dash and current is I2 dash. So now we are basically connecting them in parallel combination. So this will get shorted here. Maybe this I will shift it to black. So both the inputs are shorted and now this is our input terminal. So the new input becomes plus minus V1 and say the current is I. Maybe I'll call it IA and this current is IB and this voltage is plus minus V2 or maybe V1. So V1, V2. So now can anyone tell me what will be my IA and IB? What is IA? What is IB? Again, the objective is same to this I want to represent as a single two-port network. Okay, so someone mentioned in the chat, IA is I1 plus I1 dash and IB is I2 plus I2 dash. Yes, very good. So here we'll have IA dash, IA is equal to I1 plus I1 dash and IB is equals to I2 plus I2 dash. And we have V1 equal to V1 dash because they're parallel connection and V2 is equals to V2 dash. So now I'll ask you one question. So in this case, which parameters we have to use or which one will make our life simpler? Y parameters, Z parameters, T parameters, H parameters. So same logic what we have applied in the previous case, we have to apply here. So anyone? Which parameter should we use so that we can combine it into a single two-port network? Since currents get added, Y parameters. So Nandini is saying Y parameters. What about others? Y parameters. Samrita is also saying Y parameters. So yeah, the correct answer is Y parameters. Let us find out why Y parameters. So we have for Y parameters, we have I1 and I2 on the LHS side, say for network one, and the Y parameters we Y11 and Y12 and Y21 and Y22 into voltages, which is V1 and V2. So we have V1 and V2. Similarly, for network N2, we have I1 dash and I2 dash on the LHS side, and let the parameters be Y11 dash, Y12 dash, Y21 dash, Y22 dash. And voltages are V1 dash and V2 dash, which are same as V1 and V2. So now this becomes my equation 1 and this becomes my equation 2. So now what I'm going to do is I'm going to do exactly the same thing what I had done earlier. I'll do equation 1 plus equation 2. So I1 and I1 dash addition becomes IA and IB, which are my new input and output currents here. So IA and IB. So this is my IA, right? So we'll have IA, or I can say I1 plus I1 dash and I2 plus I2 dash, which are my new currents for the new network, is equals to, we have summation of this Y parameters, Y11 plus Y11 dash, Y12 plus Y12 dash, Y21 plus Y21 dash, Y22 plus Y22 dash into the common voltage, which is V1 and V2. So now if you see in the case of series connection, the impedance matrix is the summation of the impedance matrices. Here, if you see, we'll get the somewhat slightly different. So it is the admittance matrix, right? So the admittance matrix. So the admittance matrix of a parallel connected two-port network is a summation of admittance matrices of the individual two-port network. So is this concept clear for everyone? And this is our two admittance matrix. So is the concept clear for the series connection, how we'll get the net matrix, and for the parallel connection, how we are getting the overall matrix? Any doubts until this point, anyone? Before we proceed further? Okay. So people are saying they're clear, no doubts. Okay, now we are going to cascaded two-port network. We have two-port networks, two-port networks basically cascaded. So let us see. First, let us name them N1 and N2, and let the voltages and currents be defined. And this is the output. Okay. So I'm defining the voltages. This is V1 and this is I1. This will be I2. This will be V2. This will be V1 dash. This will be I1 dash. And this will be V2 dash. And this will be I2 dash. So now this is the overall network. What we are trying to do is, now again, we are trying to do the same thing. We are combining this into a single two-port network. And let us call that two-port network as N. Okay, so now in this case, how are we going to proceed further? Which parameters are helpful and why? Okay, first of all, can anyone tell me the relation between I2, I1 dash and V2 and V1 dash? Looking at the circuit. Okay, someone is saying V1 equal to V1 dash equal to V2. Yeah, very good. So we have V1 dash is equals to V2, and then I2 equal to I1 dash. So Nandini is saying I2 is equals to I1 dash. Is that correct, or what about others? What do you think? Minus I1 dash.
Minus I1.
Yes, I2 equal to minus I1 dash, or I1 dash is equals to minus I2. Okay. So now which parameters we have to use? Any idea, or what do you think? Because we have to combine two networks, and this is my input and this is my output. So I have to get relation between V1 I1 and V2 I2. So which parameters will be good? Yes, Parvatam says I1 and I2 dash are input and output. Yes. So this entire network becomes my new network N, and I want to get a relationship between these two. So which parameters makes my life simpler? And any idea? Z. Chandrasekhar says Z parameters. What about others? Output of one is input to the other, so ABCD. So Nandini says ABCD because the output of one network is the input of the other network. What about others? What do you think? Let me see if others have any thoughts in their mind. Then we can proceed. So Shamita says ABCD and Parvatam says also yes, sir. So yes, ABCD because input of one is output of another port. So we can substitute that and then we can get the overall relationship relationship between the input of the first network as well as the output of the second network, which is the output of our single two-port network. So let us see how it is going to help us. So let us start with the network N1. Input and output. If you remember, the input is V1 as well as I1, and the matrices are matrix terms are A, B, C, D, and then here it is IV2 and minus I2, because we have said that minus I2 is the load current, so that's why it is written in that form. Now N2, what is my input? Input is now V2 and I2. So V2 and V1 dash and I1 dash. I'm sorry. So V1 dash and I1 dash is my input. Is equals to, let the matrix be A dash, B dash, C dash, and D dash. And then the voltage, output voltage is V2 dash and minus I2 dash. Okay. So is this clear until this step? Everyone?
Yes, sir.
Okay. So now what we are going to do is, we know that V1 is equals to V2 and I1 dash is minus I2. So what I'm going to do is, I'm going to substitute the equation 1 in equation 2. So let us call this equation 1 and let us call this equation 2. So substitute equation 2 in equation 1. Substitute equation 2 in equation 1. So now what we are going to get? We are going to get the input output relation, which is V1 I1 is my input, equal to product of matrices, two matrices. First matrix is A, B, C, D. Second matrix is A dash, B dash, C dash, and D dash. And the last matrix is V2 dash and minus I2 dash. So now this becomes our input as well as the output, and this becomes our new ABCD matrix. So is this clear why we are using ABCD matrix and how it is going to help us to get the relation between the input and output simpler, in a simple way? So if
Yes,
we
sir.
have to summarize, yes. Yes, any doubts? The ABCD matrix of cascaded two-port network is the product of. So we have the ABCD matrix of a cascaded two-port network is the product of ABCD matrices of the individual two-port network. So any doubts until this point? Anyone? Is it clear for everyone until this point?
Yes, sir.
Okay. So in that case, let me summarize, because now we are going to solve a few problems. So this week it is all about series, parallel, as well as cascaded combination of two-port networks. So we have started with the series combination of two-port network, where we have connected two networks in series. Because they are connected in series, currents will be same and voltages will be added. So it will be easier for us to consider Z parameters, because in that case we can simply add both this equation 1 as well as equation 2. So now once we add equation 1 and equation 2, we'll get that the impedance matrix of the series connected two-port network is nothing but the summation of the impedance matrices of the individual two-port network. Now, if we go to the parallel combination of two-port network, here the voltages remain same and currents will get added. So we have to consider the opposite of that, which is the admittance matrix. So here, if we get the admittance matrix of network 1 as well as network 2 as shown in equation 1 and equation 2, now we can simply add equation 1 and 2 so that we can get the admittance matrix of a parallel connected two-port network as the summation of the admittance matrices of the individual two-port network. Now coming to the cascaded two-port network, here, the network N1 is cascaded with the network N2. So the output of network N1 is the input of the network N2. And in this case, it will be helpful or also easier if we consider the ABCD matrices. So we have considered the ABCD matrices of network N1 as well as network N2, which will give us equation 1 and equation 2. Now, if we substitute equation 2 in equation 1, we can get the input-output relation of the entire cascaded two-port network, where the ABCD matrix of the cascaded two-port network is obtained as the product of the ABCD matrices of the individual two-port network. Okay, so with that being said, if you have any queries, you can ask, else we'll go to the problem solving session and quickly solve a couple of problems. So 1, 2, 3, 4, 5, 6, 7, 8 are somewhat easy. Let us start with the rest of the questions. Once we complete this, then we can go back and solve if time permits. So let us start with this problem. So this is problem 1 and problem solving session. Okay. So this is our problem solving session. And this becomes our problem 1. Okay, please read the problem, then we can start solving it. So they have given one network and they have given the Z parameters of this two-port network, which are given by Z11 equal to 40, Z12 equal to 60, Z21 equals to 90, and Z22 equals to 100. And Vs is given 30 volt, R is given as 30 ohm. And they are asking power delivered RL equals to 30 ohm. Then what is the power delivered to this resistor RL? So any confusion in the question before we start? So have you read the question? Hello. Okay. Yes, sir. So let us write the Z parameter expression first, because I know V1, V2 and I1, I2 are related by the Z matrix. So let me first quickly write whatever we know. So V1, V2 is nothing but Z parameter, which is 40, 60, 90, and 100 into V2 and sorry, I1 and I2. I1 as well as I2. Okay. So now how to proceed further? Anyone, any idea? So I want you to just think about it so that if you get any idea, then we'll see whether we can proceed further or not. Basically, they are asking power delivered to RL. So either I have to calculate V2 or I have to calculate I2. So how can we proceed and how to solve? They have given Vs, they have given R, they have given RL. Someone mentioned in the chat, Vs equals to V1, sir. is Vs equal to V1 or is it something else? There is a resistor in between.
Vs V1 is equal to Vs plus I1 into R.
Yes, very good. So let us write the equations that we have. So Vs is nothing but V1 plus I1 into R. So I can write V1 is nothing but Vs minus I1 into R. So I know Vs, which they have given 30. So I can write it as 30 minus 30 I1. Okay. Now anything about V2 that I can write in terms of I2 and RL? V2.
V2 is equal to 30 I2.
Okay. So is it correct? The direction and polarity, is it okay or something is wrong?
Minus 30 into
Minus
R.
30 into I2, right?
Yes.
Okay, very good. Okay. So now after this, what are we going to do? Or how should we proceed? So now I got whatever equations I'm supposed to get. And now still I'm stuck here. So any idea how to proceed further?
You can substitute that in
Yes, very
you
good.
can
So we'll
substitute
let
that
us
in
substitute.
V1 and V2.
30 minus 30 I1 and minus 30 I2 on the LHS side is equals to 40, 60, 90, 100 into I1 and I2. So after this, any idea how to proceed further? Also, there is less than a minute, so I think this meeting will end. Once this meeting ends, kindly join back so that we can continue our discussion. So from here, what we can do is we can get two equations, and there are two unknowns. So let us solve for it. So what is my first equation? First equation is 30 minus 30 I1 is equals to 40 I1 plus 60 I2. If I bring everything on one side, I will get 70 I1 plus 60 I2 is equals to 30. Let it be my equation 1. And what will be my other equation? Minus 30 I2 equal to 90 I1 plus 100 I2. So from this I will get another equation which is 90 I1 plus 130 I2, which will give my equation 2. So is this clear how I am getting two equations? So I have done matrix multiplication and then I have gotten these two equations. So is it clear until this point how we are getting these two equations to everyone? Or something is still not clear? Yes. Okay, so can you please now solve for I1 and I2 and let me know what are the values of I1 and I2? So what will be the value of I1 and what will be the value of I2? So I have solved, but I also want you to solve so that you can be confident about your calculation. Try to do it right. Don't try to do it in a hurry. We have time. So do it slowly, but don't make any mistake. So we are coming towards the end of this course. We are already in week 11. Next week will be the last week. So you should not make mistakes, more mistakes. So I1 is 1.05 ampere. Chandrasekhar says, very good. 1.05 amperes. And then I2 he says minus 0.72. Minus 0.72 amperes. Okay, so let us wait for others and see if they're also getting the same answer. Okay, others also please solve and check whether you are getting the same I1 and I2 values or not. Okay. Others are able to get the same expression, or are you still solving? Okay. Whoever has calculated I1 and I2, can you calculate and let me know what will be the power delivered to RL? And let me know the final value. And whoever is still calculating, once you calculate, let me know if the answers are matching with this I1 and I2. Anyone? 15.552. So Chandrasekhar is saying 15.552. Let us check. So the power delivered will be power delivered to RL will be nothing but I2 square into RL. So 0.72 square into RL. So I have calculated and I have got around 15.9. So how much he is getting? He is getting around 15.5. So let us assume that he has done it right. 15.5. So we got power equal to 15.5, which is in the range. So I assume it is correct. What about others? I don't hear from any one of you. Parvatam, as well as Nandini, Shamita, Narsaya. Have you solved? Are you getting the same answer? So the answer is in the range. So I think it's fine. 15.5.
I'm getting 15.99
Nine.
watts.
So I was also getting like that. So I was getting 15.94. So Chandrasekhar, kindly check your calculation. I was getting around 15.9. Our RL is around 15.9 watts. So kindly check your calculation. Okay. Thanks for letting me know. So has everyone done this problem? So this problem is very interesting. If you see, we don't know what is there in this. They have only given the Z parameters of this, and they have given the voltage source. They have given the resistor value, and they're asking the power delivered. So first we have started with what we know. Because they have given Z parameters, we have written the expression. After that, we have substituted V1 and V2 in terms of I1 and I2. So now it has been converted into two linear equations with two unknowns. So we have solved for I1 and I2, and then we have seen that they have asked for the power delivered to this resistor RL, which is I square into RL. So we got this expression. So is this clear for everyone? If you have any doubts, please ask before we proceed to the next problem. Okay,
Yes.
clear. Okay. So now let us solve one very interesting problem. This problem. So this problem, there are wide range of questions. So let first see the understand the question. So okay, this will be our problem two. But this is very interesting. Once I have solved, like there are many questions, wide range of questions. Okay. So they have given this circuit and they have given resistor to be 16 ohm and K to be 1. So this will be our problem 2. And then they are asking these are which parameters?
ABCD parameters.
Everyone agree ABCD parameters?
Z parameters.
Z parameters, yes. So these are Z parameters. So first we have to solve for Z parameters. So after EFGH, they're asking some more questions which are also quite interesting. We'll get back to these questions slowly, but let us first solve for these Z parameters. So let me import the expression from the first page where I have written the yes. So this will be So this will be our Z parameters, right? Okay. Okay. So this will be our Z parameters. Okay. So now, either we have to make I2 equals to 0 or I1 equals to 0 and solve. So let us make I2 equals to 0. So how are we making I2 equals to 0? Should we short it or open circuit or what should be done?
What we should find in this question, sir?
EFGH, EFGH. So we have to find Z11, Z12, Z21 and Z24. So how, let us start with I2 equals to 0. So what should be done? Open circuit, right? Yes, people are saying open circuit. So let us make I2 equals to 0. And let me redraw the circuit. So we have three resistors here and KI1 here. Okay. Resistor 1, resistor 2, resistor 3. Here we have K into I1. And this is open. And this is V1, I1. And resistor, how much they have given? 16 ohm. 16 ohm, 16 ohm, 16 ohm. K is 1. So this is I1. And this is plus minus V2. And I2 is equals to 0. Okay. So basically, when I2 is 0, I have to calculate V1 in terms of I1 as well as V2 in terms of I1. So how are we going to proceed? Anyone, any idea? How we can proceed? No one? No idea? V1 by I1 is equals to Z11. Yes, but how are we going to calculate Z11? We have to solve this circuit, right? So how are we going to solve this circuit? So I need V1 and V2 in terms of I1 and V1 and V2 both in terms of I1. So how are we going to proceed? How are we going to solve? Okay, so let me tell you, this is what? This is my V1 and this is what? This is my V2, right? So that is V1 and this is V2, right? So let us assume the direction of the currents. Let the current is flowing like this. Okay. So now let me apply KCL at both the nodes, node 1 and node 2. So at node 1, what will be the expression for currents? Current entering equals to current leaving. So what will be the expression?
I1 is equal to V1
I1
by
is equal
16
to V1 by 16.
plus V1 minus V2 by 16.
Yes. Very good. So now I can write this as 2V1 minus V2 is equals to 16 I1 and I'll mark this as equation 1. What about the other KCL? If I apply KCL at node V2, what will be my current entering equals to leaving expression?
V1 minus V2 by 16
Okay.
plus I1
Yes. Very good.
equal to V2 by 16.
Yes. Very good. So now I have obtained two equations. Let me also write this in the same way. So we'll have V1 minus 2V2 equal to minus 16 I1. So can someone calculate and tell me what is V1 and V2 in terms of I1 so that I can write it here. So what is my V1 and what is my V2 in terms of I1? Calculate and let me know. Is anyone solved?
V2 by I1 is equal to 48 by 3, 16, sir.
16 and V1.
Is Z1.
Hello. What is V1?
Z21, sir.
But what is V1 in terms of I1? I want V1 in terms of I1 as well as V2 in terms of I1.
3V2 is equal to minus 16 I1.
Now you tell me V2 in terms of I1, V1 in terms of I1. You solve the circuit and let me know the final answer. So someone said V2 is coming 16 I1 and what is the value of V1? This is just simple equation. Why it is taking so much time for you?
3V2 is equal to minus 16 I1.
Hey, you tell me V2 in terms of I1. Why are you giving me the task? You tell me V2, take it to LHS, and then what is there on the RHS side, you tell me. And then let us cross check with everyone if it is matching or not. And also calculate V1, don't tell one expression. And once you get both V1 and V2, substitute it in one of the equation and see if it is correct or wrong.
V1 is equal to 16 by 3 I1.
Okay. And V2,
V2 16 I1.
okay. So if we substitute this in the equation one, will it hold good? Did you get my point? It is not LHS is not
Yes,
equal to
sir.
RHS, right? So there is some mistake. Please cross check. This is the like simplest equation. Like you just have to multiply one term, one equation by two, and then subtract one from the other. I'm not sure why it is taking so much time and so many mistakes.
So V1 is also 16 I1s.
And V2 is also 16 I1.
Yes, sir.
Okay. I hope others are able to do. This is a simple calculation. You should be able to do. So if we do this, we'll get Z11 equal to 16,
Z21 is equal
Z21
to
equal to
16.
16. Yes, very good. So others are able to get the same expression. Hello. Others are able to get the same expression. Shamita, Parvatam, Nandini. Are you getting these values? Z1 equal to 16 and Z21 equal to 16. Nandini is saying she's getting 16.66. Just check whatever V1, V2 you are getting, substitute it in one of the equation and check whether whatever you are getting is correct or wrong. Basically, what you have to do is you have to multiply equation 1 by 2 and then subtract equation 2 from that. So you'll have 4V1 minus 2V2 equal to 32I1 and 2V2 will get cancelled. On the LHS side, I have 4V1 minus V1, which is 3V1. On the RHS side, I have 32I1 minus of minus 16I1, which is 48I1. So 3V1 equal to 48I1 means V1 equals to 16I1. If you substitute it here 16I1, you will get V2 is equals to 16I1. So it is very simple. I'm still surprised why it is take so much time and still you are not able to get the expression. Like this is a simple equation, right? There is not big calculation also, and it is just two equations. Very simple. And looking at this, if you see 16I1, 16I1, this will be 2 into 16I1 minus 16I1 equal to 16I1. This is 16I1 minus 2 into 16I1, which is minus 16I1. It is like we can see. So has everyone calculated or someone is had to calculate? Got it. Okay. So let us solve for I1 equals to 0. So I'm just copying this. Let me copy this. So now we are solving I1 equals to 0. So I1 equals to 0. So now this becomes my I2 and this becomes my I1 is equals to 0. Okay, so now you know that this doesn't have any value, right? So I can basically simply erase this. Okay. So now I have to calculate for again V1 and V2. So can anyone, now I have to calculate V2 in terms of I2 as well
0
as
is
V1.
equal to V1 by 16 plus
Okay. V1 by 16
plus V1 minus V2 by 16.
Okay. Very good. So now if I do, I'll get 2V1 equal to V2.
2V1 minus V2 is equal to 0, and that means
Yes, yes,
2V1 is equal to V2.
yes, yes. Very good. And what about the other equation?
It is I2
I2.
is equal to V1 by 6, V2 by 16
Okay. V2 by 16.
minus, and
Uh,
I2 plus V1 minus V2 by 16 is equal to V2 by 16. V2 by 16.
so from here I'll get V1 minus 2V2 equal
2V2
to
is equal to
minus
6 minus
minus
16 I2.
16I2. Yes. Okay. Now please solve for V1 and V2 and again substitute it back so that you can cross it. Don't solve for one and let me know. Solve both and cross check and then let me know.
Okay, okay, sir.
V1 is equal to 5.33 into I2.
Okay, so it is 16 by 3, right?
Yes, sir.
V2 is equal to 32 I2.
Yes, very good. 32 I2 by 3. This is also 32
Yes.
I2 by 3. So from this, we can get what parameters?
Z
Which parameter?
into Z12 is equal to 16 by 3. Z22 is equal to 32 by 3.
Yes, so we'll get Z12 as well as
Z22.
Z2, which are 16 by 3 and 32 by 3. So in the question, they are calling them EFGH. So if I write it as EFGH, uh, we got E and G as 16, 16. So this is 16, this is 16,
16
16
and
into
F, F is
5.33
equal to 16 by 3.
and
Something
10.66.
10.66. Yes, sir.
So let us check whether our values are correct or wrong. So E is 16. So E is 16, well within the range. And F is 5.33. So F is 5.33 in the range. G is also 16. So G is in the range. And H is around 10.33. Sorry, 10.66. So it is also in the range. So E, F, G, H are correct. Right? Everyone agree?
Yes, sir.
Till this point, is it clear? Because whatever we are going to do now, it is a little bit tricky. If you have any questions, you can ask. Else, we'll proceed further and see uh, how we are going to solve the other questions. Is it clear till this point?
Yes, sir.
Okay. Now, let us go one by one. So they are saying we define the open circuit voltage as AV equal to V2 by 2, V2 by V1, and with port 2 open circuit. So they are saying they define something called open circuit gain, which is called as AV or defined as AV, which is V2 by V1 with port 2 open circuit. So how are we going to solve this problem? Anyone?
Sir, we have when I2 is equal to 0, V1 is equal to 16 I1, V2 is equal to 16 I1. So from that we
Yes.
can find
Yes.
gain as 1.
Yes. Very good. Very good. So we have already solved for I2 equals to 0. So port 2 open circuit means I2 is equals to 0. And in this case, we have solved and found that my V1 is equals to 16 I1 and V2 is equals to also 16 I1. So from this, I can get my AB to be equals to 1. Agree everyone? How we are getting AB to be 1? Because I2 equals to 0, we have already solved these parameters, right? V1 as well as V2. So they're asking when I2 equals to 0, what is V2 by V1, which is 1. So my AB is 1. Any doubts in this question?
Yes, sir.
Clear. Okay, now let us see and solve this 15th question. So now they are saying port 2 is short circuited and then what is minus I2 by I1. So port 2 is short circuit, so voltage is 0. So now they are asking,
V2 is 0, sir.
sorry, V2 is 0. Uh, now how are we going to solve for minus I2 by I1? Any idea how we can solve?
So we can take the admittance, I think,
Okay, or any
because
other idea?
shorted.
If we do not have to solve the question again, then any idea how we can get? Say we have Z parameters, and from Z parameters, can I do anything? I can again solve the circuit, but I don't want to solve the circuit again. So then any way to do or there is
I2
no.
is V2 by R. V2 by Z plus.
Okay. Then
Then V2 is 0, so I2 is 0, so AI is 0.
no. See, I2 is not 0, right? V2 is 0. V2 equal to 0 does not imply I2 equals to 0. Okay, so someone is saying take the inverse and V2 equals to 0. So Parvatam says V2 equals to 0. So what I'm going to do is, let us consider this first and let us see what we can do from this, or if we can do anything from here. Okay, so they're saying V2 equals to 0, right? So what if I substitute V2 equals to 0? So now anyone see any idea, any thoughts?
Yes, sir, we can write I1 and I2 in terms of V1. It's cancelled, I think. So the V1 is equal to Z11 I1.
Z21 plus Z21 I1 plus Z22 I2 is equal to 0.
Yes, very good. So Z21
From
I1
that,
0 equal to Z21 I1 plus Z22 into I2, right? And what is my Z21 and what is my Z22? Anyone, what is Z21?
Z22 is 16 by 3, sir. So
Z2
32 by 3
and Z21?
is 16. I think
16 I1 plus 32 by 3 I2, right? So now can anyone tell me what is my AI, which is minus I2 by I1?
32 by 1.
So from this, let me know what is AI, which is
It is
minus I2 by I1.
Z22 by Z21, sir. That is
Parvatam says 3 by 2. Prano
16 by
says
3, sir. It is
just calculate and check. So
16 by 3,
Parvatam,
sir. It is.
how is it 16 by 3?
Sorry, 2 by 3, sir.
Or is it 3 by 2?
1.5 minus 1.5.
Okay, check. I'm giving the question. You check if there is any mistake, cross check and let me know. So Pranav is saying, sir, I have a query about exam question paper and also in some assignment questions. Can I ask now or later? Pranav, we can have this discussion towards the end. I'll solve this problem and I'll solve one more problem, then we can discuss. So AI, what is the value of AI?
2 by 3, sir. It is
Uh-huh.
0.66.
1.5.
Okay. So Chandrasekhar, can you check? It is minus I2 by I1, not I1 by I2. Can you cross check again and let me know what is the answer?
It is I2 by I1. So that 2 by Z2.
How much? Minus
Yes,
I2 by
sir.
I1.
Yes, sir. Yes, sir. Yes, sir.
1.5, right?
3 by 2. Yes, sir. 1
Yes.
point.
So if you see, we need not solve the circuit again for IT equals to 0 because we have the parameters. What we have to do is, sorry, V2 equals to 0. We just have to make V2 equals to 0 and then solve for V1 or I1 or I2 because they're asking ratio. So we need not solve the circuit again. Even if you solve the circuit again, you will still get the same answer which you can try. But we need not do because we already have solved the problem. So interesting, right? Like in this problem also, you can do the same. You can put I2 equals to 0 and then you can solve V1 by V2. We can get V1 in terms of I1, V2 in terms of I1. So V1 by V2 is nothing but Z11 by Z21, which is 16 by 16. So you are getting 1. But we have anyway calculated it. So we have proceeded with that way. But you can solve it in the similar fashion also. Now let us solve. So they're saying find the resistance seen in port 1 when 16 ohm is connected at port 2. Okay, so this is also a little bit interesting, similar to the problem that we have solved at the beginning of today's class, the very first problem that we have solved. So anyone, any ideas how to solve this? So all these are very interesting because like they are different type of problems. Okay, so we have V1 and V2. So from this, what can we get? If 16 ohm is connected, what can we infer from there? Port 2, they have connected a 16 ohm. Or maybe I'll give a clue. Let us go top. And here, so they have connected 16 ohm here. So what will be the relation between V2 and I2? They have connected 16 ohm here.
VT is equal to minus IT into RL.
Yes, very good. And now they're
So VT
asking
is equal to minus 16,
minus 16 I2, right? And they're asking
16
what
I2.
is
Yes.
the resistance seen from port 1. So what will be the resistance seen from port 1?
That is Z
V1
Z1
by I1,
to
right?
Z1.
V1 by I1, right?
Uh-huh.
So one thing
Yes,
you
sir.
have to
Z11.
remember, Z11 is V1 by I1 when I2 equals to 0. But whatever they are asking V1 by I1. So you have to properly solve for V1, properly solve for I1, and then divide it. Z11 is V1 by I1 at I2 equals to 0, not V1 by I1. So in the question, they are asking V1 by I1, not at I2 equals to 0, because I2 cannot be
Okay.
0, because there is some resistance they have connected, and it may or may not be 0. We have to solve and see whether it is actually 0 or not. Clear? Everyone, the confusion why it is not Z11?
But how minus 16 I2, sir?
Okay, just a minute, I'm coming. So this is 16, this is 16 by 3, this is 16,
32
and this is
by
32 by 3. So they said they have connected a resistance at port 2. So similar to this problem. So in this problem, how did we say V2 is minus 30 I2? Because RL is 30 and current is I2. So similar way, they have connected here one resistance, say R. So V2 will be minus I2 into R.
Okay, sir.
So here the resistance value they have given 16. So that's why it is minus 16 into I2. Clear?
Yes, sir. Yes.
Okay. So now let me write the equation, two equations that I will be getting. So I'll get V1 equal to 16 I1 plus
That's 16 by 3 I2.
16 by 3 I2, and the other equation is minus 16
Minus
I2,
16 I2 is equal to
16
16
I1
I1
plus
plus 32 by 3 I2.
32 by 3 I2. Basically, what you have to do is you have to substitute this 16 I2 here, and then, sorry, not exactly that. You have to solve for I2 in one equation and then substitute it in the other equation, and you have to solve for V1 by I1. So V1 by I1 is equal to Z11 only when I2 equals to 0. Else if you see V1 by I1 is not 16. It is something else. Some other term is also there. So now basically what you have to do is you have to solve for V1 by I1 and let me know what will be the value. So solve for V1 I1, substitute like solve second equation, get I2 in terms of I1, substitute it in the first equation, and let me know V1 by I1. Don't make any mistakes. Anyone got the value? 32 by 3. So Nandini is saying 32 by 3, but I think it is not 32 by 3. Kindly check, cross check, and let us wait to hear from others. There is less than a minute, so this meeting will end soon. Kindly join back. We will solve a couple of problems which are also very interesting. And I guess this problem is interesting. I have selected this because it is having so much content, and there are many different type of concepts that will be covered in this problem. And as you see, there are wide range of problems that we are solving from a like the same circuit. So I think this meeting might end. Let me write the value quickly before it ends. So you will get V1 by I1 as 12.8 ohm. Just cross check, I'll wait. So I have written that this meeting might end. So just cross check. I'll wait until you solve and confirm whether you're getting the same answer or not. Yes, sir. Parvatam is saying yes, sir, 12.8. What about others? This meeting might end. Please join back so we can continue our discussion. Okay, so are you getting the same expression? I'll give you a couple of more minutes. You solve and let me know whether you are getting the same answer or not. Kindly cross check and let us see if everyone is able to get the same expression or not. So this week is also simple compared to what you have done in the past week. So it is a little bit more complicated in terms of series connected, parallel connected, cascaded connection. But if you see, it is just the same concept. So basically, I would say this week is also again kind of bonus where you can score more marks and compensate for what you have lost in the earlier weeks. So, but I have seen that your people are making a lot of calculation mistakes and spending a lot of time for small calculations, which needs to be improved, and that can only be done by solving more and more number of problems and trying to do as many problems as possible and uh, trying to improve your calculations. And that comes only with practice. So you have to practice as much as possible. Then only you can solve. Even if I don't solve any problems and if I try to solve after a long time, I'll tend to make mistakes because I'm not habituated, and that's okay. But you should not uh, like accept it and be okay with it. You should uh, practice and try to improve yourself. So others are able to get the same value, 12.8, or anyone is yet to calculate
Yes, at 12.8.
12.8. Others like Chandrasekhar and whoever is there,
Yes, sir.
Narsaya, Nandini. Nandini, you're also getting. Okay. Let us solve. This is the last problem in this paragraph set. So here they are saying uh, 16 ohm is connected to port 1. Okay. And they are asking what will be the resistance seen from port 2. So let me rewrite this. So V2 is V2. What will be V1? So V2 remains V2. But what about V1? So they have connected the same way. It's now previously they have connected two port at the resistance at port 2. Now they are connecting at port 1. So what will be the expression?
16 I1.
Okay, will it be plus or minus?
It's plus 69.
And why is it so? Why not minus? Let us go
So
back.
the current direction is towards.
Okay, let us go back to the two-port network. So if I connect a resistor here, uh, the resistor is consuming the current or supplying the current? So we have a two-port network here, and let me call it network N. We have connected a resistance, and this is the plus minus V1, and this is the current I1. And here we have
Sir,
V2
V1 is minus 16 I1.
minus 16 I1, right? Because the current direction is opposite.
Yes, sir. Actually,
So
yes.
everyone agree why we are getting minus 16 I1?
So once again,
So this is V1, right? And this is I1. So if this is the polarity of V1 and I1, what will be V1? Whether it will be 16 I1 or because current is whenever the current is entering the resistance, that terminal will be positive, right? But current is leaving this terminal, which means there will be a minus sign, right? Because that's what we have learned. The bottom terminal will be positive, right? Because the current will come back and current will enter the resistor here.
yes, sir.
So V1 is minus 16 I1, right?
Yes, sir.
Okay. So now we'll get again two equations. So the first equation is minus 16 I1 equal to 16 I1 plus 16 I2 by 3, which is my equation 1. And equation 2 is V2 equal to 16 I1 plus 32 I2 by 3. So we have again two equations, two unknowns. And I need which value by which value? They're asking resistance seen from port 2. So which is what?
Z21, sir, it is. V2 by I1.
V2 by port 2, seen by port 2. V2 by
Sir, actually, port 2 means output. So, input is port from port 2.
so it is
So,
what voltage? What voltage by what current?
V2 by I1, sir, I think it is.
Why I1?
Okay, sir. Z22, sir. V2 by I2. Actually, I'm seeing that port 2, port 1, so that's why I'm got
Okay.
confused, sir.
So we have to calculate V2 by.
Z2. V2 by I2.
So is this V2 by I2 Z22 or is it not?
No, sir. Some other value.
Because I1 is
Since here
not zero.
I1 is not 0.
Yes.
Yes, sir.
Good. So yeah, again, this is also simple calculation. Don't make any mistake. Try to solve. And I hope now everyone will be able to tell me the correct answer without any mistake. Nandini is saying 8. Let
It
us
is
see
8,
what
sir.
8 ohm, right?
Actually, yes, sir. 48 by 6. 8. Yes, sir.
Okay.
8. Sir.
Good. So it will be 8 ohm. I hope others are also calculating. Let me just wait for others. So once they confirm, let me just summarize this question. If you see, this is a very lengthy question, but it is very interesting. Like from the same circuit, they have formulated so many questions. And with these many questions, so many concepts are covered. Not only the Z parameters, they have asked voltage gain, current gain, resistance seen through port 1, resistance seen through port 2. But we have not solved the circuit again. We could also solve the circuit again, but based on what we have calculated Z parameters, we have just substituted the values and then solved these two equations. So you can also get the resistance by solving the entire circuit again without these Z parameters, but that will unnecessarily waste your time and the tendency of making mistake will be more in that case. So we are solving in an easier way where the calculation mistake like the probability will be less. So everyone is getting 8 ohms.
Awesome.
Okay. So let me just quickly summarize this problem. Problem 2. I'll be uploading this as a single problem, but it has around 8 sub questions. I will not break down because uh, then people will not feel the connectivity as it is a passage question. I'll put the timestamp as a single problem. So in this question, what they have given is they have given a two-port network, V1 I1 on the input side, V2 I2 on the output side, and they have given resistance is 16 ohm and K is 1. So first they are asking the Z parameters. So for calculating the Z parameters, what we'll do is we'll put I2 equals to 0 and then calculate for Z11 and Z21, which we have done. And we got both as 16, 16. And then we'll substitute I1 equals to 0 and then calculate for Z12 as well as Z22. And we got Z12 is 16 by 3 and Z22 is 32 by 3. So we got our EFGH values as 16, 5.333, 16 and 10.666. Now let us, I think we have not checked the values. These values here, we have checked these values are matching. So after that, we have solved for the open circuit voltage gain, which is when port 2 is open circuit, which means I2 equals to 0. So when I2 equals to 0, V1 is Z11 into I1 and V2 is Z21 into I1. So AB is nothing but Z11 by Z21, which is gain 1, and it is also matching in the range. Now, in the other problem, in the next problem, they have asked what is the short circuit current gain, which is when port 2 is short circuited, which means V2 equals to 0. So in the same Z parameters, we have substituted V2 equals to 0, and we have calculated I1 in terms of V1, I2 in terms of V1, or you can directly take the second equation, which is in terms of I1 and I2. And from this, we have calculated AI is equal to minus 1.5. Let us go and check what is the value of AI. AI is 1.5, sorry, not minus 1.5, 1.5 because they have given minus sign here, and 1.5 is matching. So this value is also correct. Now let us go back. Then we have solved for the resistance seen from port 1 when 16 ohm is connected on the port 2. So in this case, V2 will be minus 16 I2, and we have substituted it and then converted these two equations into a single equation in terms of V1 and I1, from where we got V1 by I1 ratio, which is 12.8 ohm and is also in the range. The 17th question is similar to the 16th question, but in this case, they have connected 16 ohm on the other side. So here they have connected 16 ohm and V1 I1 relationship will be now V1 equal to minus 16 I1. Again, we have to combine these two equations and get an equation in terms of V2 and I2. And the ratio of that will be the resistance seen from port 2, which is V2 by I2, and we have obtained as 8 ohm, and it is also in the range. So is this question clear? Shall we proceed to the next question? Or do you have any doubts until this point? Any doubts?
Next question, sir.
Okay, next question. So probably this will be our last question for today's session. And this is also very interesting question. Okay. So this will be our problem 3. Okay. So this will be our problem 3. So please read the question, then we'll start solving.
It's series networks, two-port network.
Kind of series network, but not also exactly series network, because there are no two-port network, because we have one two-port network and then they have another two-port network outside.
It is cascaded.
Also not exactly cascaded, because we have only one two-port network and they are connecting some resistors, and then they have considered the outer network as a new two-port network. So it might not exactly fall into any of the ones that we have studied, but they are asking this is the new two-port network. New two-port network. Basically, what we have to do is we have to get relationship between V1 and V2 in terms of I1 and I2, and they have given relationship between V1 dash and V2 dash in terms of I1 dash as well as I2 dash. Okay, is that clear? You got it, right? Here the Z parameters are between V1 as well as V2, but these Z dash parameters are between V1 dash as well as V2 dash. Does that make sense? Or any confusion? Hello. Okay, so somebody is saying yes, sir. Okay, so first let us start with what we have. So let us start with Z dash. So Z dash is a relationship between V1 dash as well as V2 dash. And they have given that 60,
60, 30,
30,
60.
60.
I2 dash, I1 dash, I1 dash, I2 dash.
I1 dash, I2 dash. Yes, very good. So now let us expand this and write the two equations that we'll get. So what will be the first equation?
V1 dash is equal to 60 I1 dash plus 30 I2 dash.
And the other equation?
V2 dash is equal to 30 I1 dash plus 60 I2 dash.
Okay. So let this be our equation 1 and equation 2. So now any idea how to get the Z parameters of the outer two-port network? Like now I
So
want V1
actually,
and V2 in terms of I1 as well as I2.
I1 is equal to I1 dash, sir,
Okay.
and I2 is equal to I2
Okay. So you
dash,
are saying I1 is equals to I1 dash.
sir.
Good. And I2 is equals to I2 dash. Yes.
I2 dash. Similarly, V1 is equal to I1 60
Okay.
minus V1 dash.
Okay. Also there is 10.
Similarly, yes, sir. I mean, V1 is equal to 60 I1 minus V1 dash.
No, I'm saying, but also there is 10 ohm. You have skipped 10 ohm.
Yes, sir. V1 dash
V1,
plus 10 I1 dash, sir.
Okay, so can you tell V1 in terms of V1 dash and I1
Yes,
dash
sir.
V1 is
combined?
V1 minus V1 dash.
You just take your time and then tell me V1 in terms of V1 dash. So what
V1,
Chandrasekhar is trying to do is here he is trying to apply KVL, and here he is trying to get V1 in terms of V1 dash as well as I1 dash, and I1 dash is nothing but I1. So what he's trying to do is he's trying to get relationship between V1 and V1 dash so that he can substitute it here and he can get equation 1 in terms of V1 as well as I1 dash I2 dash, also V2 in terms of I1 dash and I2 dash.
sir, it is V1 is equal to V1 dash minus 70 I1, sir.
So V1 is at lower potential or
Plus,
V1 is at higher potential, right?
sir,
Yes,
plus
yes. Very good. Very good.
70 I1.
So you are saying V1 is equals to V1 dash plus 70
Plus 70 I1, sir.
I1 or I1 dash. And V2, can you tell
I1,
what
sir.
is
Or
V2?
I1 or I1 dash. So,
I1 dash,
so,
both are same, yes. V2,
so once for the diagram, sir. Sir, V2 is equal to V2 dash plus 80 I2, sir.
okay. V2 dash plus
Plus
80
80
I2
I2
dash.
dash.
Okay, so from this, how are we going to proceed further?
In the place of V1 dash and V2 dash, we can replace these values.
Yes, very good. So now can you tell me what will be the modified expression?
So it is V1 minus 70 I1 dash. That is equal V1 is equal to 130 I1 dash
Okay.
plus 30 I2 dash.
I1 dash I'm replacing by I1 and I2 I'm replacing by I2,
Okay,
right?
sir. Yes, sir. You
Okay,
can
very good.
replace I1, I2.
And then V2,
And similarly, V2 is equal to 110 I1 plus 60 I2. Sorry, sir. 30 I1 plus 140 I2.
yes, very good. So from this, can you tell me my Z parameters?
Sir, it is Z11 is in 130, sir.
Okay.
You can directly write the values.
The Z11 is
130,
130,
130.
Z12,
Z21 is 30, sir.
okay, and Z21.
30, Z22 140.
So is this clear for everyone how we are getting this, or any doubts? Basically, what we have done is we have written what equation they have given for V1 dash I1 dash as well as V2 dash I2 dash. So it is 60, 30, 30, 60. And they are connecting some resistors here and some resistors here, and they are calling the outer box as a new two-port network, and they are asking what will be the Z parameters of the outer box. So it is neither cascaded nor series. We cannot say exactly because again you have to consider this as a two-port network as well as this as a two-port network, but it looks like it is in cascaded, but it will make things complicated. So it will not directly come under any of those things. Basically, what we need is we know I1 equal to I1 dash, I2 equals to I2 dash. And we need the new Z parameters, which is in terms of V1, V2 should be in terms of I1 and I2. So if we directly apply KVL here, I can get V1 in terms of V1 dash, I1 dash, V2 in terms of V2 dash, I2 dash. So V1 is nothing but V1 dash plus 70 I1 dash. V2 is nothing but V2 dash plus V2 dash plus 80 I2 dash. So now I have obtained V1 in terms of V1 dash, I1 dash, V2 in terms of V2 dash, I2 dash. But what is V1 dash, V2 dash? That I can get from this Z parameters of the inner two-port network. I'm getting this. So now I have substituted this in this equation. Now I got V1, V2 in terms of I1, I2. If we write the matrix, I'll get 130, 30, 30, and 140. Let us check whether the answers are correct or wrong. So first one is 130, then 30, then 30, and then 140. So here they have not given any range because it is straightforward and you have to give the correct value. So this is not range based, it is just direct answer. So is this clear? Is this question clear for everyone? Or any doubts you have? Please ask me if you have any doubts.
So we are substituting V1 value,
V1
V1
dash,
dash
V1
value in
dash.
V1 now, sir.
Yes, yes.
Then, yes, sir, but there is one I1 dash now, sir, but you put I1.
Yes, because I1 dash is I1 and I2 dash is I2. Both are same. So that's why I have replaced it here.
Okay, sir.
So I have skipped that term, like that step, and I have directly written. Is that okay? Any further queries? In case no, I'll just summarize this week's session and then I'll conclude today's session. So week 11 is about series, parallel as well as cascaded combination of two-port network, or it could be any other combination. But we have started with these three combinations. So we have seen that in series combination, it would be good if you use the impedance matrix because we can get the impedance matrix of the series connected two-port network as the summation of the impedance matrices of the individual two-port network. Whereas in the case of parallel connection of two-port network, currents will be added up. So we have to get in terms of admittance matrix. And we have seen the admittance matrix of the parallel connected two-port network is the summation of the admittance matrices of the individual two-port network. Similarly, if we are connecting two two-port networks in a cascaded way, then we can see that we can use ABCD matrices because the output of the port 1 is the input of the port 2. And then we got the ABCD matrix of the cascaded two-port network is the product of the ABCD matrices of the individual two-port networks. However, we have not solved any direct problem on these three, but it is equally applicable once someone gives the ABCD of this, ABCD of this, and if they ask the ABCD matrix of the entire thing, you have to do the matrix multiplication. Similar type of problem were not asked in the last assignment, so that's why we have not solved. But we have solved some interesting problems like this problem where they have a two-port network whose Z parameters they have given, and they have a voltage and resistance here and a resistance here. Now what we have done is first we have written the Z parameter equation, and we have seen V1 is nothing but Vs minus R into I1, which is 30 minus 30 I1, and V2 is nothing but minus 30 I2. So we have substituted. Now it becomes two equations, two unknowns. We have solved for I1 and I2. Once we get this, we can again solve for V1 and V2 if needed. But in the question they have asked what is the power delivered to the resistor RL. So we have calculated I2 square into RL, which is obtained as 15.9 watt. In the second problem, which is like one of the like good problems that we have solved today, and also wide range of sub questions. So here they have one V1 I1, V2 I2 input and output ports, and they have first asked for the Z parameters. So we have considered I2 equals to 0 and solved for Z11 and Z21. Then we have considered I1 equals to 0 and solved for Z12 as well as Z22. Once we get the Z parameters, then we have solved the other questions which we have not solved earlier or in the last week, where they're asking open circuit voltage gain, which is given by V2 by V1 when port 2 is open circuit, which means when I2 equals to 0. But we have already solved for V1 and V2 when I2 equals to 0 and they are equal. So V2 by V1, which is the voltage gain, will be equal to 1. Similarly, they are asking short circuit current gain, which means when the port 2 is short circuited, what will be the current gain, which is given by minus I2 by I1. So port 2 short circuit meaning in the given Z parameter expression, we will put V2 equals to 0. And using the second row, we can get the relationship between I1 and I2, and AI, which is minus I2 by I1, was obtained as 1.5. And then in the next question, they are saying they have connected a 16 ohm resistance at the port 2, and then they're asking what is the resistance seen from port 1. So if 16 ohm is connected at port 2, V2 and I2 relationship is nothing but VT equals to minus 16 I2. So we have two equations, three unknowns, but they're asking the ratio of V1 by 1. So substitute I2 from the second equation in the first equation. So you will get equation in terms of V1 and I1. So now if you divide V1 by I1, you will get as 12.8 ohm. Now going back to the last sub question of the second problem, they are now connecting 16 ohm at the input. So V1 is now minus 16 I1. And now they are asking what is the resistance seen from the port 2, which is V2 by I2. So again, substitute I1, first calculate I1 in terms of I2 and substitute it in the second equation. Now the second equation will be in terms of V2 and I2, solve for V2 by I2, and we have obtained it as 8 ohm. Last problem is also a little bit interesting, where they have one two-port network and they have connected four resistance, and now they are calling the outer two-port network as a new two-port network, and they are asking the Z parameters of the same. So first from the inner two-port network, I can get V1 dash as well as V2 dash in terms of I1 dash and I2 dash. Now after connecting these four resistors, I can calculate V1 dash in terms of V1 dash, sorry, V1 in terms of V1 dash I1 dash as well as V2 in terms of V2 dash I2 dash, which we have obtained. After getting that, equation 1 and 2 can be substituted in these two equations. And now we can get V1 in terms of I1, I2, V2 in terms of I1, I2. And that will give us Z parameters, which are obtained to be 130, 30, 30 as well as 140. Same thing, they can frame it in a different way. And they can also ask Y parameters of the output two-port network. But don't start with the Y parameters. Start solving for Z parameters, and now you can calculate for I parameters, because we should always choose that path which is easier and which will reduce the calculations drastically. So this concludes our week 11. If you have any questions, you can ask, else we can wind this session up. Any questions?
Sir, can
anyone?
you show the first two questions that we not solved so that we can verify your answers by solving our own?
This problem.
Yes, sir. This one, that one, sir.
Okay.
And answers also, sir.
Okay.
That we
Okay.
can try on your own and we can verify, sir.
Okay. Then one thing I'll do, I'll put it in my notes. Also, I'll upload. So
Yes, sir.
you can get it.
We'll take a screenshot
Yes,
and we
yes.
can verify the
Also,
answers.
these notes will be uploaded to my drive. So from there you can access. So basically, this is just a similar problem to what we have
So that we
solved in
solved
the
in earlier week.
earlier week. So that's why I have skipped.
Yes,
So
sir.
let me write the values y11, y12, and y21 and y22. So once you solve this, you will get something like this: y11, y12, y21, y22. So if we solve, you will be getting 3, -1, and -1 as well as 7. So this is the expression. And problem 4 has another subset which is very straightforward. So they're saying these two are connected in which fashion, parallel or series? Let me put. So is this
Parallel.
the
Parallel.
parallel connection? So what happens to the admittance matrix of this new two-port network?
Just addition, sir.
Addition. So it will be multiplied by 2. Okay. So multiplied by 2 means because we have obtained that, now we can also obtain this. So it was
So it is y11 square or
no, not y11 square. Actually, that is a very poor representation from their side. So they are calling these new parameters as y11 2, but that is very pathetic way of representing. So basically, they are asking the new set of y parameters, which will be summation of both, and both are same. So multiplied by 2. So we'll have 6 minus 2 and minus 2 as well as 7. So this is very simple problem, and there is no much inside compared to the problems that we have solved. That's why I have skipped. However, you can solve. So Parvatam, how to solve this?
so once show the answer, sir, for second
Yes.
one.
Okay. So how to solve this problem? Basically, these are y parameters. So you have to make v2 equals to 0 and solve for y11, y21, as well as v1 equals to 0 and solve for y12 and y22, which we have solved in the last week. So you can go through that video and see how we have solved. Same thing, you have to make v1 0 as well as v2 0 and solve for y11, y12, y21, y22. This will be the answer that you'll be getting. And kindly note that this is not resistance, this is conductance. So resistance, okay, that's also a good thing. So the resistance value here will be 1 ohm. Here it will be half ohm. And here it will be 1 by 6 ohm. So better
Actually,
to
it is
solve in resistance and then later convert into conductance. So
impedance.
kindly note that.
Yes.
Yes. So any other questions?
No, sir. No, sir. Thank you.
So please solve this. Today we didn't get time. However, it is easy problem. So you can consider this as homework. Once you get this, this is just simple and straightforward. Just a parallel connection.
So
Okay,
that's
if you
to verify
face
our
any,
answers. We are asking answers, sir. Actually.
yes, yes. Also, these notes will be uploaded. So from there also you can get. I'll try to edit by tonight. I have some other work, but let me see if I can edit and upload it quickly.
Sir, actually, in the next 12th week, we are having some op-amps. Actually, it was not covered in syllabus, sirs.
Yes, week 12 is about
It was
op-amps in
mistake
the.
or
No, no, it will be op-amp. The videos they have covered op-amp, right? Sir's lectures.
actually in the syllabus it was not mentioned, sir. Only networks
Okay,
is
okay.
there in
Actually, they
syllabus.
might have missed. Week 12 is about OPEP, but it is simple and straightforward. You go through search lectures and
Okay.
then we'll discuss again in detail. Or you can go through my earlier year OPEM session also where I have explained. But it's up to you. Else we can discuss again in the next week. Also, there will be another 1 hour additional problem solving session on next Wednesday, which will be just to summarize what we have discussed. And if you have any further queries, you can ask before your final
When
exam.
when sir? When
Next
sir?
Wednesday, I think 7 to 8 probably. Also, the NPTEL team will
That
give you the update.
means 16th, sir.
I think, yeah, 7, meaning 8, 9, 16th. Yes, 16th. 16th from 7 to 8
That
p.m.
is the last
Same
day to
link.
submit the last assignment, sir.
Like
That day.
next Monday, 6 to 8 will be week 12 problem solving session. Next Wednesday will be just a summary session where I'll summarize what we have discussed. Or if you have any queries, we can also discuss on that.
Okay, okay, sir. Thank you.
Okay. Okay, with that, I'll end this session if you don't have any queries. And I wish you all the best for your week 11 assignment. Again, we'll meet again on the next week, 6 to 8 p.m. next Monday, discussing about opens. Yeah, thank you. Thank you everyone for
Okay,
being
sir. Thank you.
attentive. It
Good
is a
night,
nice
sir.
session. Yeah, thank you. Good night.